So now I'm gonna show you the easy way of adding the essential to the program. Since potentiometer represents the voltage divider, we need to take two resistors and plate them, connect them in a series. Here we have one input terminal, another input terminal, and we're adding the third terminal, which is adjustable. Now we need to create the labels for these terminals. So we go to edit and we go to label nets. Let's make this one. This is our second and the third terminals. Basically, after we're changing the parameters to make the complete potentiometer, this R1 is changed to RA for more convenience, and we should use these brackets, RA brackets. And the same we're doing here, brackets RB brackets. And now just to assign the desired parameters, so we need to go to spice directive dot parameter, and RA equals to R multiplied by value divided by 100, and we're editing it here. So basically this R is the total resistance for whole potentiometer, and the value is the position of adjustable terminal in percents. For example, if the value is 50, it means that the adjustable terminal is right in the middle. And now we just need to do the same exactly for RB, right? Parameter RB equals to R multiplied by 1 minus value divided by 100. And we do this, just 1 minus value divided by 100, to decrease the value of RB when the value of RA increases. And basically the RA plus RB, the total sum of these two parameters, will be always equal to the R, the total resistance of the whole potentiometer. And this is the key point of potentiometer, actually, to give any fraction of the potential across the ends of the resistors. So next we just need to save. We go to File, Save As, and here we go to LT here, and we write POT, which is a potentiometer. We already had it, but let's replace it and do it once again. And now we need to create the symbol for our potentiometer. Usually it is represented as a resistor with an additional arrow on schematics. So we will do here the same. We'll take the symbol for the resistor and adjust it. And to do so, we go to File, Open, and we just need to be sure that there is the symbols, and because that will make our job a little bit easier. We need to go to Lib, then to Symbols, and here we just need to find the resistor and open. This is the symbol for our common resistors, and we can simply save it as to the same file that we have our previously made scheme. So the name should be exactly the same. It's a POT, and the difference only the extension. So because this extension is for the schematic symbol. So, and we save. And now we can simply get rid of these names. We don't need them, and we also don't need these blue rectangulars, which are the input port pins for resistor. But as we already know, this is not resistor anymore. So we also need to add additional layers here, and to do so we can first just move these parts here for a while, and with the duplicating, with the copying, can copy this part here, this here, and return this to the original position. And now we can even zoom out or zoom in for more convenience. We need to add some arrows we need to add an arrow here, and we can do it the same way with the duplicating. We can duplicate this once again and mirror, and then rotate it, but we don't need to rotate it anymore. There we go. And we can draw the simple line to get the shape of the arrow like this, and the arrow is completed. And now we just need to assign the port pins to each port. So we need one here, another here, and the last one here. To do so, we go to edit and then add pin or port, and the label name should be exactly the same labels as we had on the previous scheme. So we put here 1, then we do it again, we put it 2, and we put 3 here. And basically now we just need to add some values for the total resistance and for the value of adjustable pins. And to do so, we simply go to edit and the attributes and edit attributes. First of all, we get rid of this R because this is not resistor anymore. And in the description, if you like, you can write that this is not a resistor, but it's a potentiometer. And in the spice line, you can write the value for R. It's the total resistance of the potentiometer. Let's make it 5 kilo ohm. And the value is 50. That means that the adjustable terminal is right in the middle. And both of these values can be changed anytime you wish. Which we push the OK. And then we go to attributes again, and to attribute window, just to give the name, the instant name. That means that the instant name will change as we add more and more potentiometers. The default instant name is the X1. If we add like 2 potentiometers to the circuit, they will have name X1, X2 respectively, and so on. Now we just need to save this. And now, just to make sure that everything is done properly, we can make a simple test. It's a simple circuit consisting of voltage source and our potentiometer, and we can vary the parameters of the potentiometer. First of all, we go to components and we go to the file where we have our potentiometer. There we go. Edit here. As you can see, it's X2, X3, and so on by adding more and more potentiometers. We also need the voltage source. Let's put it here. Also, let's put the ground here, and let's just connect the voltage. And we theoretically know that's a very easy circuit. We are just using the Ohm's law, and we will simply measure the voltages. Here we have voltage, let's say 5 volts. And here, by right click, we can choose these parameters. You can add or reduce the total resistance and vary the adjustable pin of the potentiometer. So let's leave these values as for now. And let's simulate it. We see that input voltage here is 5 volt as expected. Let's measure voltage here. And as we can see, the voltage here is 2.5 volts. That's exactly what we wanted because the value of our resisted potentiometer is 50. So it's right in the middle. So we got the desired voltage. We also can measure the current just to make sure that we have all the correct data. If we divide 5 volts over 5 kilo ohms, we'll get 1 milliampere by Ohm's law. So here we should have 1 milliampere, and that's exactly the value that we got. But now let's change the value from 50, let's say for example 10. That means the adjusted pin is on the 1/10 of whole length. So the expected voltage is approximately 4.5 volts because it's 90% of initial input voltage. If we measure the input voltage, it is the same 5 volts. And now this voltage that we have on this pin is exactly the 4.5 volts. We got the desired voltage. And we can vary these parameters in any way you wish. So basically, that's all.